back for section 2, I see. Alright, 10.2 is all about something called independent and dependent events. I'm guessing that from the name of this section, you guys are going to be able to figure out what independent and dependent are. Independent means that one thing does not affect something else, and dependent means that something affects something else very strongly, right? Okay, so independent is something that does not affect something. So that's what we're going to start with. Independent means that two things do not have anything to do with each other, okay? So independent, something does not affect something at all. So the way that you figure that out is, let's say that I want to, so the way that this is written is probability of A and B. So like I flip a coin and I roll a die. Okay? They don't have any impact on each other. I flip a coin, I roll a die, good, whatever. So probability of A times the probability of B. So like this is the, you know how when people always talk about like rolling die and, you know, like what's the probability that you roll a 7? And they always say there's 36 possible combinations on a die. Well, yeah, because you could roll one die and the other one doesn't have any effect on it at all, right? You have a 1 out of 6 chance of getting a number right on, or a number on the first die, and you have a 1 out of 6 chance of getting a number on the second die. That's where it's actually coming from. Okay? So that's where we talk about the independent events. But like the example that we're going to go over specifically deals with the let's say we want to roll a 6 and we want to flip tails. Okay? There's one way to roll a 6 and there's one way to roll a tail, or to flip tails. We multiply those together, which means that we already decided there were 12 outcomes of this thing, right? There's only one way to do what we wanted to do. So if you watch 10.1, 10.1 was all about figuring out the outcomes, which we just confirmed is 12. And then it says that there's only one way to do that. You flip tails, then you roll a 6, right? So there's only one way to do that. That's what independent events look like. Okay? So let's look at a new example. Okay? I'm just going to read this out loud, and then I'm going to kind of talk to you about something. Okay? So think of a question that has think of a quiz that has 4 questions. All right? It's got 4 questions on it. You don't know anything. You don't know a single thing about it. All you're doing is guessing. Okay? You have 2 outcomes for each question, right? You're either right or you're wrong. So you have 4 questions, and you're trying to guess on every single one of them. We want to know, are questions 1 and 2 independent? Are questions 1 and 2 independent? Well, here's what could happen, right? Here's question 1 and here's question 2. What could happen is you could get it right and you could get it wrong. You could get question 1 wrong and you could get question 2 right. You could get question 1 right and question 2 right, or you could get question 1 wrong and question 2 wrong. That covers every possibility, right? And now the questions, is it independent to guess 2 questions, 1 and 2, right? There is one way to guess 1 and 2 to be correct, so you have a 1 out of 4 chance of guessing 2 questions right? As long as they're, you know, right or wrong, true or false, so you have a 1 out of 4 chance. Now if we look at question 1 individually, question 1 we have a 1 out of 2 chance of getting right, and question 2 we have a 1 out of 2 chance of getting right. 1 over 2 times 1 over 2 is 1 over 4. We just figured out 2 different ways that 1 over 4 was the probability for this thing, which means that the answer to the question is yes, they are independent. We're trying to figure out whether they're true or whether they're, you know, independent or not. There's 4 total possibilities, one way to get it right. And then if we look at the other way, which we just said with independent, if they're independent, then these 2 things should be equal to each other, which they are. Alright? The next part is talking about dependent, and this one's a little bit trickier for people to get their hands on. The best way that I can think about this is, so the way that they write this is the probability of A given that B happens. Okay? Probability of A given B. So that line means given, and what you're going to do, actually, hang on. So the probability of A and B happening is the probability of A given, and then probability of B given that A happened. So the best way that I can explain this is, let's say we want to draw 2 kings from a deck of 52 cards. So we want to draw 2 kings from a deck. We all know that there are 4 kings, right? There's hearts, clubs, spades, and diamonds. So there are 4 kings. My first card that I draw, I have a 4 out of 52 chance of drawing a king, right? Now what it means with dependent events is I want to draw 2 kings, so I'm going to draw a king and hold it in my hand. How many kings are now left? Well, we took 1 away, right? We're saying this part right here, this probability of B given A, this part right here is specifically saying you have drawn a king. You're holding the king in your hand. So given that A happened, well, A said that I wanted to draw a king. You've done that. So now there's only 3 kings left in the deck, and there are only 51 cards left in the deck because one of those cards is left in my hand. So the probability of drawing 2 kings back to back is going to be 4 times 3, which is 12, over 52 times 51, which is 2,652, and when we compute that, if we do 12 divided by that number, we get just over 0.45%. So it's literally 0.45%. You don't even have a 1% chance of drawing a king. And think about that. If there's 52 cards in a deck and only 4 of them to choose from, drawing 2 kings back to back is going to be really, really challenging. Alright? So the next one, here's another example. Let's say that in an envelope, in something, you have 20 $1 bills. And then you have 5 $100 bills. Alright? Now I'm asking you what the probability is. So here's the probability. So here's A is the first event and B is the second event. The first event is what's the probability that the first bill I draw is a 100, and the second one is the second bill I draw is $1. Now I know right now there are 25 total bills, right? So the probability of A and B, the number of bills depends on how many bills I take out, right? If I take a bill out, I'm all of a sudden at one less bill than I was before. So the probability of A and B is going to be 5 over 25 times, and I've taken a bill out, but it wasn't a $1 bill, right? It was a $100 bill. So there are still going to be 20 $1 bills in there, but there aren't going to be 25 bills in there anymore. There's going to be 24 bills. So now it's going to be 5 times 20, which is 100, over 25 times 24 is 600. So it's going to be 1 over 6, and 1 over 6 is roughly 17%. So you have a 17% chance of this thing happening. Okay? So this is how these are going to work. The last example, very last example, so situation A is that 60% of students buy lunch. So 60% of students buy lunch. Situation B is 10% of students who buy lunch get dessert. Okay? So 60% of the student body buys lunch. Of that 60%, 10% of them buy dessert. So now the question is, what is the probability that someone who buys lunch, also buys dessert? So the question is, what's the probability that someone who buys lunch also buys dessert? Okay? So basically what I'm saying is, we already know the probability that they buy lunch. We already know the probability that they buy dessert if they buy lunch. So it's going to be the probability of B given A, which is going to be 0.1 over 0.6. I want them to buy lunch. That's what I want. That's what they're going to do. The total number of people comes out of buying lunch, but I also want them to buy dessert. So this is what I want. I want them to buy dessert. 10% is what happens when they buy dessert. And then someone who buys lunch is 6%. Again, that is 17%. Okay? Now, if you want to see more examples, ask me about it, but I'm trying to keep this video a little bit shorter because this is one where this is a really hard thing to teach because this is a lot of common sense. This asks you to kind of go outside the box and start thinking and figure out what probabilities look like. So this is going to be something where you're going to have to kind of work on the worksheet a little bit and ask me questions about it. If something doesn't make sense, ask me. I will be more than happy to work my way through and kind of talk with you about it. But again, we're trying to keep them kind of short so that you're not doing too much in one day. Ask me questions if you got them. See you next time.